Alright, let me lay this on you. Up here, our letterhead. Them are the breadcrumbs to me. You want a copy? You want to get to me? Use any of them. Telephone, fax, email. Alright, let's get on with the show here. You see, the name of this video is called The Trigonometry Silver Bullet. Alright? You're going to say, what the hell's this fool talking about? Let me tell you something. I tripped over something the other day using my smartphone that's a game changer. And I want to lay it on you. I'm talking to any machinist who has to do trig to cut angles. Most machinists, or a big bulk of them, have a blind spot when it comes to trigonometry. I'm trying to bring it down to the lowest common denominator. With a smartphone, the pain in the ass trig becomes Mickey Mouse. You see what I got here? Two sine bars, one on the left, one on the right. When you set a sine bar, see my mouse? You got to put gauge blocks. The word is blocks. Multiple gauges that stack up to a height. You stack them up, the gauge blocks, relative to the distance between the rollers. Alright? You got a 4-inch sine bar, the gauge blocks are a certain height. You got a 5-inch sine bar, the gauge blocks are a little taller. All that's to get this angle right here at the top of the bar, exactly what you want. See this thing? Follow the mouse. It says gauge block, sine bar, trigonometry. 3 buzzwords. That's what this is all about. Let me take you to the magic I discovered. We'll start this way. Read this. Let's play make-believe. Let's make believe we got to cut a taper on a lathe. Now we have 2 drawings side by side for exactly the same part, right? One drawing calls for a 12.436 degree taper, okay? The other drawing calls for 12 degrees, 26 minutes, 9.6 seconds. Guess what? Follow the mouse. They are exactly the same, just expressed differently. Alright? The objective as a machinist is to set your sine bar to the correct angle. No shit, Sherlock. Alright, let me move this up. First, the sine bar gauge block stack height has to be calculated. And as I previously said, different lengths of sine bars require different stack heights. Alright? Well, how do you... First of all, let's use... I got a little formula I learned in trigonometry in high school. Right here where the mouse is. Sine of the angle times the length of the sine bar equals the gauge block stack height. You see that right there? For this video, we're using 12.436 degrees angle. Alright? Using a 4-inch sine bar, the stack height equals 0.861957, blah, blah, blah. Alright, I'm going to bring some up here. See this? Well, let me bring it down. This. Put a pin in it, right? Stack height. See that number? Forget the 0.8613 or 8614, right? Remember that, because we're gonna refer back to it. Are you confused? How do we get there? I tripped over the silver bullet on my smartphone. Alright? I tried this technique multiple times on Android or Google and iPhones. It's time to show you the magic. Sine 12.436 degrees times 4.
The answer is approximately 0.86.
Put a pin in that. Alright, let's try the next one. Sine 12 degrees, 26 minutes, 9.6 seconds times 4.
The answer is approximately 0.86.
Alright, put a pin in it. See ya. That's good. Okay. Okay. Now that you have seen the magic, allow me to elaborate. Obviously, now that you've seen the magic, you can instantly calculate any drawing angle. Any angle on a drawing, you can get it with your smartphone. But what if you want to cut a known taper? Right? If you want to cut a known taper, you'd have to hit the books to find the correct angle. It looks like here comes another time-consuming mission. Well, you know, you got to hit the books. Once you define the angle, you have to calculate the stack height. Yeah, and back to the same bullshit. The stack height is relative to the length of your sine bar. Doesn't this piss you off? Forget the books. We got you covered. Lathe compound sine bar, that's what we sell, includes charts for most standard tapers. Morse, Jono, Brown & Sharp, Jacobs. I'll show you them. I'll show you the charts in a minute, but let me get to this. The charts show, the charts that I'm talking about, show the angles, the stack heights for 3-inch sine bars, 4, 5, and 6-inch sine bars. Alright, let me lay these charts on you. Show you what they're about. Take a look here. We'll start with the Jacobs taper because it's the shortest amount. Show you what these charts do. All the way to the left, Jacobs taper. See my mouse? Goes from 0 to number 33. From Jacobs, go to the right. Large end, small end, length, taper per foot, taper per inch, angle from the center line, and here's the key part right here. See where the mouse is? That's the 3-inch sine bar, 4-inch sine bar, 5 and 6. Shows the stack height. See the number there? No trig needed. See where the mouse is? No trig. All that data is in there, all relative to the Jacobs tapers. Let me move on to the next one. Morse tapers, same format. From Morse taper 0 to number 7, same format from left to right. Small end, large end, center, angle from the center line, sine bar stack height. See it says right here, sine bar, gauge block, stack heights. Alright? Move on to the Jono tapers. They all say this. See where the mouse is? No trig needed. These are all going to come in lathe compound sine bar. They're all going to be charts inside the box. All laminated in the sleeve. You can't get them dirty. Same format. Big key right here. Sine bar, gauge block, stack height. See it right there? I'm trying to go quickly here. No trig needed again. Look at the Brown & Sharp tapers. It goes from 1 to 18. That's a hell of a lot of tapers. You see it? Same format. Small ends, taper per foot, all that horse shit. Sine bar, stack heights. Right? You don't have to know shit. You just got this thing, pull out the chart, see what size sine bar you want, and you're ready to rock and roll. One more. This one here, how to cut a taper, a drill chuck taper in a lathe using a lathe compound sine bar. It's all the same format. Alright? Jacobs, see it over here, Jacobs chuck, Jacob's taper, straighter taper shank. It's all there. Tons of information. Alright, I just wanted to show you what's in the charts that are in the lathe compound sine bar. That's close to 100% coverage. That brings new meaning to the phrase, we've got you covered. Do yourself a favor. Forget the trigonometry. Use the lathe compound sine bar. Let me get you back up here. Here's the breadcrumbs. I'd like some comments on this to know if this is worth anything to you. Breadcrumbs again, telephone, fax, email. Guess what? I'm out of here.